sorry for the inconvenience. This is a talk, not technical. I wanted to share with you a story, our long-term project that I hope that can open some discussion or open your curiosity to share experience in similar context. Let me introduce myself first. Okay. My name is Francesco Merlo, and I started my first ZOP project in 2003, more or less, when I was a developer at the University of Torino. Then I moved in Pisa as a developer for RefLab in 2007. And that's me, my first day of work in RefLab during the Plone conference in Naples. And probably we can do a restaurant also here. But if you found other people that are in this picture, yes, you will win nothing. And now I am a RefLab associate until now. Generally speaking, my work is as a full stack developer, because I work from front-end, back-end, but I also do project management sometimes. And I usually call myself as a technical leader because I have the most overview of each project. Why this talk? As I said before, I like to talk about stories, about a real project, instead of very technical ones. And this is the reason I wanted to share this. I'm not usually a speaker, so this is my first time that I do a talk at all. Okay, so the challenge of the project that I would like to share with you is for Doctor Without Borders, that you may know also as MSF. They have a different name in different countries. They need a tool to easily distribute manuals, books, policies related to the logistic knowledge in places without or with lack or not stable internet connectivity. And they need to get the access very quickly, because when they have an emergency, they have to save lives, save things very fast, and they have to find the knowledge in many manuals, very long and very technical. So this is the challenge that was proposed to us. We had some constraints. The first constraint was that, first of all, there is the need of a website, very typical website, but very lightweight, because it should be accessed very fast in those zones. Then they need also a USB key version, because they're used to do trainings before going in the missions. And at the end of a training, they use it to give the person something physical. They started with manuals, then they moved to DVDs, and finally they decided to switch from DVDs to USB key. And at the moment, the USB key is the physical device that is used. Another constraint was that the same website with the same contents and the same features should also be accessed through a local NAS in the local office in the missions. So they have a NAS that is connected to a router that has a custom DNS, and when they go to the URL and the domain of the website, they are redirected to a local copy of the website to be more quickly, or to get the information of the website even if the office doesn't have any connectivity. And as I said, all the features and all the content should be available in these three contexts. So the solution that we proposed at the beginning was, okay, let's do, first of all, a static website. We cannot base the website on a CMS. We should have the same information on a portable app on a USB key, some kind of portable app, and then do the synchronization of the NAS of the static website. Okay, and this is more or less a logical diagram of the solution. Some numbers. These are the current numbers. So we have more or less 50 locations with limited bandwidth. So 50 NAS distributed in the world that should be synchronized. Every training, they distribute 100, 200 USB keys to different persons that brings them to the field. We have more than 500 topics, so is the organization of the knowledge that is split in 500 different topics. Voices, I'm sorry, I did some short movie, but I didn't have the time to share the presentation with the movies. As you can see, we have topics related to biomedical or specific diseases like cholera. Then there are more than 100 knowledge, I call them knowledge assets. There are very long book, very technical book, or are the manual instruction of, I don't know, satellite phones or other technical things that they need to use or repair at the moment. The project started in 2012, and we are still working on it. We work with limited budgets, so it's something that is incremental every year. The first year we started with 100 books, few topics, and less than 1 gigabyte of data to distribute, and now we are with these numbers. So at the beginning, it was pretty simple, the solution. It was implemented in a pretty simple way. So we started with a Plone on a shared hosting to limit the cost. We developed a tool for dumping the Plone website into a static website, similar website. We started with Google Gears, that at the beginning was the only stable solution for dealing with offline implementations. And then on a Chrome portable as a portable app. So we installed the Chrome portable on the USB key, we synchronized the contents of the static website on the key, and then distribute it. Now the architecture has been evolved. We time by time introduced a new solution, new technologies. So now we have the shared hosting was converted into a more sophisticated AWS-based architecture. So by basing the services on what AWS provides. Plone is still the CMS that we use for managing the knowledge for the editors. Then we wrote a real web app instead of just a simple static website. So that is separated really from the contents and all the presentation. We implemented a bit of API system for the website, and everything is based on HTML5 technologies wrapped into NWJS, so the Node WebKit framework that is used for a desktop application and can be used as a portable app, because the Chrome portable wasn't more supported, and we have to change the technology. Okay, I will share something about the pillars of the project. So first of all, the CMS, that obviously is Plone, because we love this CMS. We are skilled also on this CMS. It is based on an AWS EC2 hosting. So it's still based on archetypes, and another important pillar is the Python library PyPDF, because we analyze the documents that are inside the CMS to extract metadata information that I will explain later. On this CMS, we developed the custom features and the custom requirements. First of all, the static dumper. The static dumper is, I will explain here. Okay. There was just a small presentation, but it is not so important, just to show that it is real. So we implemented this static dumper as a walker into the website, then using the Zopa3 component architecture, we developed the adapter for each content type to define how this content should be dumped on the file system as a static resource. And we implemented this using a preview and public flow for editors, very similar to the printing way of printing books. So they print the website. The responsible of the website did a check, and then goes the OK for the real publication. So editors can dump more times the same websites, but it is the main editor that decides to push it in production. Also on the CMS, there is what we call the knowledge repository. So it's a big folder with many books. Each book is related to the various translations that it has. So they have policies that are translated in English, French, Spanish, and Arabic. So we have to treat them as one asset of knowledge and relate them. We manage useful the metadata, like the cover, classification type, and so on. But the most special feature that we have is that editors have the possibility to logically split the book into the main contents and identify the main topics that can be useful on the field, so when the people are working during the emergency, so that everybody can reach the knowledge that they need in that moment. And they have to do the same on all the translation. So for example, if there is the instruction for an earthquake safe house or something like that in the manuals in 4 different languages, we know that in the English one is from page 10 to 12, in the French is from page 11 to 21, and so on. So every document, or most of the document, are split logically into parts. Because in this way, we created what we call the assisted navigation. So a cross navigation through the books. So if somebody is looking for information about cholera, probably the information is spread into many publications of MSF, and they have to know from page 10 of that manual, and then page 24 of the other policy, and then they have to look at the checklist available on another book. And we created this kind of assisted navigation. This is not so hard for us developer, but very hard for editors to do this kind of work, and we have to support them a lot on this activity. As I said, we started with 100 books, now we have 1,000 books, and everything is getting always complex. Finally, another nice things that we do recently, just for lowering the cost, the back office is now on demand, so we don't have a Plone always up and running, just for changing some metadata and then producing the static website. So they can wake up the server on demand, change the metadata, adding a new book, press the button for do the dump, and then shut down the server. And thanks to AWS, they can lower the cost in this way, and Plone is just used when they need. At the beginning, we implemented this like with a button on a page. Could be also a IoT button, for example. Or now we have a proxy, so you go to the URL, you get a service page that say, okay, the service is waking up. Please wait 1 minute, and then it's ready. Pro and cons, from my point of view of the CMS, the pro are, from my opinion, the ZooDB, the component architecture that helped us to quickly change the organization of contents, doing migration, adding attribute, adding metadata, and so on. The component architecture for the dump, and all the authorization and workflow that Plone already provides. The cons, I say that SharePoint is everywhere, so MSF has SharePoint as a standard internally, and when we say, okay, we use Plone, oh, what is Plone? We don't know what is Plone, why Plone, and we have to explain a lot of things every time. So Plone, it is not so popular as other system, and this is something that gives us some issues sometimes to explain the benefits. And our governance with so many files and metadata and relations, so we have to build many reports to help the editors to check if everything is correctly related, and also the learning curve for new developers. This is another issue that we have. Okay, very fast. Then the app. The app is based on these 3 pillars, so it's jQuery and Mustache. Implemented with jQuery and Mustache. We use a custom version of PDF.js, that is the Mozilla PDF reader that is included in the browsers. And then Filer.js, that is a POSIX-like abstraction, so you can interact with the storage of the data as a POSIX file system. And what we have implemented, so what we can say powerful search, because it's a search that works offline, so in the portable app without internet connectivity, so has to be built and client side at all. It's a search that does an almost full text search, a faceted search, implements the operators, and permits a multiple download of documents, so you can search and then create a package that they can distribute, so to other people, and also ranking everything that works offline in the client applications. Sinks, okay, so when the editors dumps a new static website, the user that have a USB key that has been distributed can plug the USB key or the desktop application and get the updates of just the data that have been changed. So they don't have to re-download again the whole website. So they just download what has been changed, because the bandwidth is very limited. So if a policy has been updated because there was a mistake, they just plug, there is a pop-up that here I cannot show, that say there are updates, okay, please go. Another important thing is that they can filter what they need, because sometimes there is an emergency, they have to be very fast to get the updates, so they can decide just to download some topics of the whole website, so they have to download instead of 1 gigabyte, just a few hundreds of megabytes to have the information that they need. We do also integrity checks, because the connectivity is not stable, so we have to check that, ensure that everything that we declare that has been downloaded is there, because if you go offline and then you go in the fields and you discover that the file is corrupted, it's a big issue. So when we do the synchronization, we have also to do some integrity checks that are not so easy just with the client side. And do size and timing estimates during a sync. We have to say the person, okay, you have to wait 1 hour to get all the data, or just a few seconds. Okay, Smart navigation, more or less what I said before. We split all the books for a cross navigation. We have customized the PDF reader so that when they click on a link, they are directly placed on the pages that they need. There is some visual information of the part of the PDFs that is interesting for him for that topic. And then other small feature like sharing and bookmarking that in all these situations are not so easy to manage. Pro and cons. Okay, the pro, we did a very hard separation of the front-end side to the with the presentation side, with the content side of the CMS. The same architecture can be reused for the website, the desktop application, but also theoretically with a mobile application. They didn't request us also a mobile application such iOS or Android, but technically is an architecture that can work also in this context. There is no requirement for Plone competencies for working on the app because it is a pure front-end application. Cons, we have many limits for the offline on the HTML file, Chromium, jQuery. So we discover that every time that we introduce a feature or every time that the volumes increase, we discover new features that are not so well known. So we have to discover on while working on it. For example, the amount of memory that requires parsing a JSON, the amount of time required to perform an operation using the browser, and so on. Then we have also other tools like the integration with the NAS, as I said. There is also a user dashboard, and finally a data collector tools. This is another different things like a simple, what is in a classical context, a simple things like a contact form. It is not easy when we have these three different contexts. The contact form should work on the NAS, and what we do if the NAS is offline, how we get the content information, should work also in some way when they plug the USB key and they have to submit an information, an issue they have to. And so we have implemented a form that can be written in the app, saved, and in case transmitted via other channels, such as via email, or they can try in a different moment to submit the form. Okay, some lesson learned. On the other side, there is the sentence that my colleague Michelangelo, that is on the front-end side, while me I'm more on the back-end side. When I say, okay, we have to do this, it's impossible. Okay, let's try a way to solve this issue and provide a solution. And we have learned to think the use cases offline first. So when the customer requests us something, okay, let's start from the most difficult use case, that is the offline. What should happen when you are offline? Then we have learned to be more smart when finding solutions. So we know a lot of many complex technologies, Elasticsearch and so on, while we have to work with just a few JSON, a SQLite database, and a few JavaScript, and we have to make it very fast and provide something that is pretty good. Maybe it is not the top, but it's good. So we have to fine-tune any solution. Okay, let's remove this, let's simplify this part, and then we will have a nice result. The monolithic approach is bad. We have learned from this project that when you separate the front end, so we started in 2012 with this approach, and we found that it works. So separating everything while we was used to work everything in Plone. Finally, the testing is very expensive. because we have to test the same feature on offline, on a NAS, and so on. In the future, we would like to change in the near future to Plone 5. Now it's still based on Plone 4. Introduce other technologies such as Electron, use more Node.js, and for sure Gatsby. It's an hot topic now in the Plone community to make a static website using Gatsby. Probably Angular, React for the web app technologies, and more serverless architecture for the back office. And that's all.